Yeah, welcome to this GLSL basic tutorial of GLSL, and with Touchdesigner let's program the GPU. So we're inside Touchdesigner. Let's click on the tab. Let's create a GLSL top. Here's the GLSL top. We can either program the pixels of the GPU or the vertices. We're going to look at the pixels. So again, the difference is that, okay, before we see the difference, let's do the following thing. So we are going to take the GLSL module, we are going to link it with a null, and we're going to click on this blue icon to display both the output of the GLSL and the output of the null. So we have both outputs, so we can always see the output on the right, and we can see, and let's hide this, we can see the code on the left. There it is. Okay, so what is the difference between programming the CPU and the GPU? With the CPU, we are sequentially, one by one, very quickly, changing one thing at a time. But with the GPU, we are in parallel, all at the same time, changing loads of different pixels. For example, in this case, all at the same time. So if we go to the GLSL module, we click P for the settings, we go to the common, we change the resolution to 1000 times 1000, that is 1 million pixels. Okay, so what's gonna happen when we look at the code, there is this main function. Let's delete these comments. And by the way, if you want to write on the code, on the bottom right, you click on this icon, okay, and now you can type. So we delete these comments. So there is this main function, and this main function is gonna execute in parallel for all of those million pixels all the time, continuously, in parallel for the 1 million pixels all the time, all at once. Okay, so what is the output of this GLSL module? It says, this line says there is an output that is a vector of 4 components in the variable frac color, and frac color is equal to TD output swizzle of color. So TD output swizzle, you don't have to worry about it. This is a construction structure in Touchdesigner to make sure that the output in Macintosh and PC are the same, so that the output looks the same on a PC and a Mac. This is the instruction that makes it possible, so you always put this, you don't have to worry about it. So, and the color variable is a vector of 4 components, that is the red, of course this is the red, green, blue and alpha channels. So if we want to make it black, we'll do 0 for the red, 0 for the green, 0 for the blue, and 1 for the alpha, and that's it. Now everything is black. Good. This is a good beginning. Okay, now what if we want to change the pixels? Because for example, I could go here and I could say the red component, I want to make it 1. Okay, so now everything is red. Okay, but what if I don't want to make it all the same? What if I want to do some pixels one color and other pixels another color? Okay, so this is what happens. Touchdesigner is going to give you a variable that is called bub.st. Okay, and what this is going to contain are the coordinates, and we're going to see what happens if I do, for example, the red channel equal bub.s. Boom, we're going to see what this means. So what is bub.st? So bub is going to contain the horizontal and vertical coordinates of each pixel. So the first one is the S, and it contains the horizontal coordinate that goes from 0 to 1 from left to right, and the second one, the T, is the vertical coordinate that goes from 0 to 1 from bottom to up. Okay? So what happens is that as those 1 million pixels are continuously being updated and the code is being continuously executed in parallel for the 1 million pixels, but each of those pixels has a different coordinate. Each of those pixels has a different S and T in the VUB variable. Okay, so when I say that the red channel should be equal to bub.s, what's happening is that when the pixels have a 0 in the horizontal coordinate, that's gonna put a 0 in the red channel, so it's gonna be black. And as the horizontal coordinate moves to the right towards 1, it's going to get more and more red because of the instruction. Okay, that's what's happening. Cool. Now, in Touchdesigner, you can refer to the different components of a vector with different letters. So you could use RGBA, or you could use X, Y, Z, W, or you could use ST, or you could use 0, whoops, 1, 2, oops, 3, okay? You will use different ones depending on, this is just to help you, because at the end of the day, everything that you have are the pixels, but sometimes you're gonna refer to positions and coordinates, other times to colors, so sometimes you're gonna use one or the other, but it's exactly the same thing if you put here R, okay, which is the first component, or if you put X, which is the first component, or if you put S, which is the first component, same thing. Now, what if I go to the other channel, to the green channel, and I do color.green BUB.T, the second coordinate. Boom. Now, what we have is horizontally, from left to right, we are going from black to red, and vertically, from bottom to up, we are going from black to green. Okay, so this is what you have to remember. Okay, it is from left to right and from bottom to up, from 0 to 1, horizontal and vertical. All right, next thing. Now, what if we want to create a shape? Okay, for example, we want to create a circle. So if we want to create a shape, we have to start thinking about distances. If we compare the distance of those million pixels in every single cycle in comparison with a specific point in the screen, in the grid, then we can begin to create shapes with distance functions and distance equations. For example, let's create a circle. So float circle dist is gonna be equal to a distance that is a function given to us by Touchdesigner, and we're gonna do from the coordinates, and we're gonna compare these to the position 0, 0. Okay, so that is the distance. Now, if we assign this distance to the red, for example, and let's get rid of the green for now, okay, that's it. So what do we get? What do we get in here? Look at this. The bottom left, you will see that this is the beginning of circular gradient that begins black and it gradually becomes red. It's a circular gradient. Okay, so we have a few problems here. First of all, we want to center it in the center of the grid. Second, we want it to be a circle, not like this kind of gradient thing. Okay, and third, we want to do other things with it. We want to move it and do other things with it. Okay, so the first thing is the position. Now, for the position, the first thing that I recommend is that you take those coordinates and you assign them to your own coordinate system. Vector of two coordinates UB equal BUB. Okay, so dot st. That's it. So now this is gonna be your coordinate system, and you can create many different coordinate systems. You could create 3 coordinate systems, and later we will see why this is useful. Okay, let's call them like this. That's it. Okay, so these are 3 coordinate systems. Now, what we're going to do is we're going to be playing with UB1 at the moment, and in order to center it, it's very easy. What we're going to do is UB1 equal UB1 times 2.0 minus 1.0. Boom, that's it. So what's happening here? We are transforming the coordinates from 0 to 1 to the 0 is going to become minus 1, and the 1 is going to become, and the 1 is going to become 1. Because 1 times 2, 2 minus 1, 1. Okay, so from the coordinates 0 to 1 are going to become from minus 1 to 1, and in the center it's going to be the 0.0. So that's why the 0 is now in the very center, and now we have that circular gradient right in the center as we wanted it. But this is a gradient. We want a proper circle, for God's sake. So for that we use a different function that is going to be float circle equal smooth step, and we have to give it some threshold, 0.2 times 0.3 times, and whatever we want to impact, circle list, and we assign this to the red channel. Boom, that's it. This is the circle. Okay, so what we're saying is that, you know, this is gonna be the threshold, and you will notice if I put 0.21, then it becomes really sharp. If I put 0.4, then it's less sharp. Okay, it's very cool. So this is the threshold that is gonna separate whatever is gonna be black and whatever is gonna be, in this case, red. Okay, so that's the smooth step function, super useful. But notice something very important. We want a red circle. We don't have a red circle. We have the opposite of a red circle. So if we want a red circle, we have to put 1.0 minus the circle. Boom. Oops. Boom. Okay, that's it. Now we have our red circle. Welcome home. Okay, what if we want... Notice what happens if I put 0.7, 0.72. Boom, it's bigger. So what if I put 0.2, 0.3? Boom, little one, okay? So there is our little circle. Welcome to the world. Now, what if we want to create another circle? Okay, so we're gonna duplicate these two, change the names of the variables. Very important to change them everywhere because it's very easy to forget that. And now we're gonna put minus circle 2 in the green channel. So there is the green one on top of the red, so they become yellow, but we don't want them in the same position. We want to change the position. So if we want to change the position, what do we have to do to change the position, right? Well, first of all, instead of UV1, we could put here a vector of 2 coordinates, UV1.x UV1.y. Okay, so this is gonna be the same thing. But now if I do here plus, oops, this is the keyboard between the Spanish and the English, plus 0.4 plus 0.3, boom, that's it. Now we separated them, okay? We have moved one different to the other. Okay, we have two circles, we're very happy, but we want them to move. We want them to move. Okay, so if we want them to move, what should we do? Well, if we want them to move, we have to create some data that helps us move things. So let's get out of here and let's create a chop with an oscillator LFO, two of them, two LFOs. Okay, so they oscillate with certain frequency, blah, blah, blah. So now we have to go to the main GLSL component and we have to go to the vectors area where we declare the uniforms. The uniforms are variables that are going to take information from the outside and they are going to provide it to our programming area. Okay, so we want one that's going to be pos X, another one is going to be pos Y. We also want to have a radius maybe for later, maybe. Then we want to have a time also. Now in the time we will use the Python expression abs time.frames, whoops, .frame, which is gonna give us a number that changes all the time with a number of frames that have elapsed, and it's gonna be very useful if we wanna make things change later depending on time. Okay, cool. Now we have to connect these oscillators to these variables. So it's very easy. We click on the green button, green icon to make them exportable. Okay, and then we click on the viewer. That's it. And now we just drag one on top of the value. We select chop reference and the same one with this one and chop reference, and there are the values. Now they are gonna be very crazy because they are moving very fast. So I'm going to edit their frequency. Okay, make them go slower because if not, they're gonna go nuts. And this one as well. It says the amplitude and the frequency. That's it. Let's go back to the code. Ta-chan. Okay, now we have to connect to those variables. Okay, so that's very, very easy. Very easy because we go here at the top and we say uniform float pos X. Uniform float pos Y. Uniform float radius and uniform flow time. Now always you click outside to see if you did something wrong. No, I didn't break. Good, wonderful. Okay, so now we have to connect that to the position of our friends. So how are we going to do that? Very easy, very easy, very easy. So we can do this. Look, we can do px equal float px equal ub1.x plus pos(x), and float py equal ub1.y plus pos(y). So now if we take this px and we do here vec2 px.py, boom, he came to life. The little ball, she's alive. There she's very happy. She's very, very happy. Now if we do the same thing here, px and py, boom, okay, they are both there, but you know, they are moving very similar, and I don't like that. So how can we prevent that? Let's have more fun. Yes, so let's go outside and let's create a noise chop. We're gonna create a noise chop. Boom, noise. That's it, we have a noise there. Okay, so we go to the options and let's do time slice. So it's just going to change over time. So let's connect it to a null, and in the middle let's add a math. Oops, choose the wrong one. Math, and this is just gonna set the range from 0 to 1. We're gonna make sure the range is gonna be from 0 to 1. Okay, and let's go to our GLSL. Let's call this like I don't know. Yeah, okay, go. I'm gonna call it go1. I don't know why, but you know, I feel like. Okay, so go1 chop reference. That's it, that's our go1. Okay, so now we go back to our friend here, and what if now we do, what if we multiply the px times go1, but wait, what's missing? What's missing? Yes, we have to declare it. That's it. Okay, so what's happening? What's happening is that it's going really crazy, as you can see. It's going crazy. So what we have to do is we could actually put it here and multiply it by this, for example. Okay, at the moment we can see the impact very, very little. Okay, we can see the impact very, very little, but now we can see the difference, right? We can see that the green one is moving, but it's doing that funny oscillation. So if we put 0.7 there, we can see the difference. Okay, so now they are moving different. Okay, I'm gonna put it lower, or you know, we'll go crazy. Okay, so that's an example of making one move differently. Okay, let's do something else exciting. Let's put it a little bit different. Okay, so and by the way, the size, let's make the size different. Okay, that's it. Okay, now let's make something very cool. Okay, that is to change the background, using a function that Touchdesigner has, that is the TD purling noise. It's a fantastic noise function. Okay, and we're gonna provide it with, actually we're gonna use the second coordinate system we created, UB2. Okay, and we're gonna multiply that by a noise zoom. So we're gonna create here a float noise zoom, and we're gonna make that for the two coordinates a vector 2, and we're gonna do, for example, 5.0, 5.0, whatever. Okay, so we multiply it by the noise zoom, and that's it. Oh, vec 2, very important. Okay, so there it is, and now we're going to put it in the blue channel. Noise. Boom, we got the noise. Okay, now if we put the zoom in 33, we will be getting away and we see all the zoom. Now something very cool that we can do is if we put one very large and the other one very small, we get this really cool texture. Okay, yeah, very cool. Now what if we wanted to move? Remember that we have a variable called time. So if we multiply this by vector of 2 coordinates with the first one is time times 0.07, for example, and the other one 0.02. Wow, that is moving super fast because we put times a plus. We want to add it. That's it. We want to add to the coordinates, okay, and that's it. We have it. We're moving it horizontally. So in the second coordinate system, okay, we're multiplying by the zoom and we're translating based on the passage of time, okay, times a constant. And that's nice. We have a nice background that is moving. Let's make it a little bit slower. Okay, so that's cool. Now another very important thing that I didn't tell you so far, we have put one of the circles on the red and another one on the green. Now notice another thing that we could do. If I comment this out and I put circle times circle 2, boom, they are both in the red channel now. So you can do composition of these transformations by multiplying them. Okay, you could multiply the circle times the box times the this times that, and then push them all through the same channel, or you can push them through different channels. It's up to you. Okay, but this is an option that you have, both in the same channel, like this. Okay, but let's go back to what we had, because now we want to do something else very cool. So I have right here, I'm gonna copy paste a couple of functions, so you can add new functions outside of the main function, and I have just added these two functions. So let's pay attention to these two functions. Okay, so the first function is a function for the distance, the signed distance to a box. We want to create a box. Okay, so this is a function, for example, from the website of Íñigo Quilez, a super expert in these matters, but you can find this type of distance functions all around the internet. So this one is one for a box, and as you can see, it's doing the absolute value of the coordinates to the point, and then using these maximums and minimums to get these calculations about the distance for the box. And then the other function is the rotation, and the rotation is just gonna build a matrix. Okay, it's gonna basically calculate the sine and cosine of an angle A, and it's going to build a matrix with mat2, a matrix of 2 times 2 rows and 2 columns, that is going to have orthogonal vectors, an orthogonal matrix that is going to allow to rotate vectors. So when you multiply a vector times an orthogonal matrix of this kind, you are going to be able to rotate something. Okay, so what are we going to do with this? Yes. All right, so those are the functions. So now we're going to create our box. So float box dist equal SD box. Is it called SD box? Yes, SD box. So we have to give it 2 vec3s. Okay, 2 vec3s. So in the first one is gonna be our first coordinate system.x, second coordinate, sorry, first coordinate system.y, and it's 0 because we don't have a z, and then the reference point is gonna be, well, whatever we want, you know. Yeah. Okay, good. And now our beautiful box is gonna be our smooth step, wherever we want. Boom. Okay, and now we're gonna put the box in the green channel. So let's multiply it right here. Boom, we got a beautiful box, ladies and gentlemen. We got a beautiful box. Let's make it smaller. Okay, so we have our box, and if we want our box to move a little bit, what do? We do what we always did, right? For example, we could even do this. We could replace this coordinate with py, and now we have the box moving vertically, okay, just in that coordinate. Okay, cool. Another thing that we can do now is to rotate one of the coordinate systems, but only one of them. So if we take the UV2, that is the coordinate system of the background, okay, so let's first of all let's center it. Okay, so UV2, okay, so that is completely centered. Okay, and now what we can do is UV2 equal rotate UV2 45 degrees. Boom. So notice that we have rotated one of the coordinate systems, that is UV2, but we have not touched UV1. So this is the difference. This is the flexibility that it gives you, right, to use these different coordinate systems. So if we do the same thing with UV1, so now both of them are rotated, but as you can see, we can manipulate them independently. Okay, this is very cool. This is very cool. Okay. What other thing we can do? We have the background that is moving softly. We have our little balls that are traveling around, and this is moving. And well, I think this is about it, right? So let's make a little summary. Okay, so what's happening is that you have two things that you have to distinguish very well. One is the manipulations that allow you to create different shapes and manipulate the coordinates of things, and then the other thing is through where you're going to push them onto the pixels, okay, through which channels, etc., etc. So you can do all the transformations that you want with data, and then eventually you can compose those transformations, as you can see, multiplying them and or not, and then push them through different color channels. You can use the distance functions, as we said, and you can find all through the internet different distance functions for all types of shapes to create your different shapes. All right, and then if you want to move them, right, you need to somehow get data that changes through time, and you can do that with we saw with oscillators. You can use also the time variables in Touchdesigner. You can use animated noise, and all of this external data go into the main component, into uniform variables, and uniform variables are variables that are gonna be provided to the programming environment. Okay, and then you can map these components, these modules, to those uniforms, and then those uniforms need to be declared. Of course, they need to be declared here at the top with their different classes. You can have different functions with all the things that you may need to complement your main function. Okay, and that's it. And then, as you can see, you can create your different coordinate systems, you can create different shapes, and you can use noise to modify the movements and the shapes and create different outputs. So this was a very quick, very simple introduction to GLSL, and there will be more in the future. So if you like this video, just subscribe and like it. And until the very next time, all the best. Ciao, ciao.